those of you at home, we are reviewing for the test today, and these are the instructions for the review. These guys are playing numbered heads. I'll be turning this thing off and on so that you can get an idea. But we are going to review on radical and rational equations, finding solutions to systems of nonlinear equations by graphing and graphing polynomial functions to find their key features, and that's what the test will be on. First problem looks like this. Okay, it looks like most of you got it. Remember, when you're solving a radical equation, you got to undo the radical right here. So I'm going to have to undo the cube root. I cube it. This leaves us with c minus 1 on the left side because the cube root and the cube undo each other. They're inverse operations. 2 cubed is 8. And I add 1 to both sides. And I get 9. Very good job on that one. Okay, next problem. Number 2. Here is number 2. That says, yeah, 3x minus 2 to the 1/5 power plus 6 equals 5. Okay, you guys, on this problem right here, you have to isolate the 3x minus 2 to the 1/5 because that's the radical expression first. So I have to do that, I'm going to minus 6 from both sides. That leaves me with 3x minus 2 to the 1/5 power equals negative 1. Now, the 1/5 power is the same thing as the 5th root, right? You guys remember that? It's the same thing as the 5th root. Because the bottom part of the fraction, the 5, the denominator, becomes the index right over here. And the 1 becomes the power. Well, 3x minus 2 all to the 1 power is just 3x minus 2, right? So I'm going to raise both sides to the 5th power. So I'm going to raise it to the 5th power. When I do that, 1/5 times 5 is 1. They cancel each other out. I just get 3x minus 2. 5's cancel out right there. Do you see that? Equals negative 1 to the 5th power. That means negative 1 times negative 1 times negative 1 times negative 1 times negative 1, which is negative 1 because you're multiplying by itself an odd number of times, so it's going to stay negative. Then I just add 2 to both sides to get 1, divide by 3, and I get 1/3. Any questions on that problem?
So negative 1 to the 5th power is negative 1.
Negative 1 to the 5th power is negative 1 because you're timesing, look right here, you're going negative 1 times negative 1 times negative 1 times negative 1. Let me put another one down here, negative 1. Well, if these 2 times together is positive 1, these 2 times together is positive 1, right? You still have this negative 1 down here. 1 times 1 is 1, times a negative 1 is negative 1. Does that make sense? You're multiplying by itself 5 times. Okay, we got that one? Okay, third problem. The square root of x plus 5 equals the square root of 2x minus 11. Okay, it looks like all of you guys got that one correct. I would start off by just squaring both sides because every single number is under a radical. And it undoes the left side to be x plus 5, undoes the right side to be 2x minus 11. Then I have a linear equation that I'm going to solve. I minus x from both sides, and at the same time I can add 11 to both sides. I end up getting 16 equals x. Then I told you guys to check for extraneous solutions. We should have been doing it on all of them, but the other 2 worked as well. And if you guys found out, if I plugged 16 in for x on both sides, 2 times 16 is 32. So I get this, which is the square root of 21 is equal to the square root of 21. They are equal. Any questions you'd like to ask on this problem? Okay, good job. Next problem. Which equation does not have a solution? You've got 4 equations right here. Check to see which one does not solution. Explain Explain why it does not have a solution once you find it. Okay, you guys, how many of you came up with all four of them being working? Come on, be honest here. Hey, the one that doesn't work is number D. Letter D. Okay? And the reason being is when you guys add 7 to both sides of this one, you have the square root of x plus 2 equals negative 3. Right there, that should tell you it doesn't work. Now, because is there any possible number I can put in for x, take the square root of it, and get a negative number? No, because for one thing, I can't take the square root of negative numbers. So that number inside can't be negative. And if it's positive and I take the square root of it, it's going to be a positive number. So right there, you know that there are no solutions. You would just write no solutions. Well, you could go like this. You could go like this and get x plus 2 equals negative 3 squared is I mean, if you went negative 3 squared, you get positive 9, right? Minus 2, and you get x equals 7. That's a solution that everybody thinks they're going to get. But if you try it back in there, what's 7 plus 2? If I plug it back in here, 7 plus 2 minus the 7 equals negative 10. I'm going to get square root of 9, which is 3, minus 7 equals negative 10, which is going to be negative 4 equals negative 10. So that does not work. Therefore, we have an extraneous solution. But you could have told just as soon as you notice that if once you have the square root isolated and the right side's a negative number, you know right then you're not going to have a solution. JD. How do you do A? Minus 3 from both sides, right? And you get 1. Square both sides. Square both sides, and you get x minus 1 equals 1. Add 1, and you get 2. 2 minus 1 is, if I put it back in there, 2 minus 1 is 1. Squared is 1. 1 plus 3 is 4, so that works. Does that answer your question, JD? Okay. Any others you want to ask about on here? B and C also had solutions. Okay, so the answer was D, if you did that. Okay, next one. Going to rational equation. Solve this rational equation. Okay, you guys did a good job with this one. Let me show you 2 ways to do this one. Remember, since there's a single fraction on each side, a single fraction bar, you can cross multiply on this one. I can multiply 4 times x plus 2 to get 4x plus 8. If I distribute the 4. And then I can multiply 5 times x to get 5x. Just minus 4x from both sides. And you get 8 equals x. That's one way. That's probably the fastest way to do that one. The other way to do that one is take the lowest common denominator, the LCD, which is x plus 2 times 5, right? And if I multiply both sides by 5 times x plus 2, 5 times x plus 2, what happens on this first one is the x plus 2's cancel out. I'm just left with 5x. And over here, the 5's cancel out. I'm left with 4x plus 8 when I distribute, which is the same equation we just solved up there. Okay? So there's 2 different ways to look at it. Any questions on that one? Okay? All right. Next problem. Number 7. All right, you guys did a good job on this for the most part. Hey, you guys, what's the least common denominator right here? Yeah, the LCD is x minus 2 times x plus 2. You take every factor that occurs in the denominator, okay, and x minus 2 happens, x plus 2 happens. Now, I know x minus 2 happens twice, but they're in separate terms, and so you're not going to take it twice. If there was 2x minus 2's in the same term, then you would use x minus 2 twice. But in this case, you're just going to use it once. So I'm going to multiply this side by x minus 2 times x plus 2. And I know the x minus 2's are going to cancel out. On this side, I'm going to do the same thing, but I got to distribute it. So this is going to be x minus 2 times x plus 2. And the x plus 2's cancel out. And over here, x minus 2 times x plus 2. And the x minus 2's cancel out. That leaves me with x plus 2 times x minus 4 right here. And right here, I'm left with x minus 2 times x minus 2. And right here, I'm 1 times x plus 2. If I use a distributive property to multiply these two binomials together, I'm going to end up with x squared minus 2x minus 8, right? No, because you're going to end up with a 2x and a negative 4x that will add up to negative 2x. And then right here, you're going to get x squared minus 4x plus 4 plus the x plus 2. Well, at this point, you guys, it looks like it's a quadratic equation because it has an x squared, right? However, you notice that there's a 1x squared on both sides. If I subtract x squared from both sides, I get negative 2x minus 8 equals negative 4x plus 4 plus x plus 2. Okay, I've reduced it to a linear equation. And I just have to gather like terms on the right side, which is going to be negative 3x plus 6. If I add 2x to both sides, I know you guys usually like to gather the x's to the left side, but actually, let's do that. So that's an easier way to do it. Add 3x to both sides. And add 8 to both sides. Because we're going to gather the x's to the left side. And we get x equals 14. How many of you guys checked for an extraneous solution on this? What'd you find out? Yeah, it works out, okay? It works out. This is not an extraneous solution, okay? So, and do you guys all remember how to check for an extraneous solution? Okay, plug 14 back in for all the x's and simplify it. Okay, next problem. I put a tough one on there for you. You guys did an excellent job on this one. Let me remind you on this one right here, this factor is to be n minus 2 times n plus 4. So when I multiply n minus 2 times n plus 4 on all of them, because that's the least common denominator, the n minus 2's are going to cancel out here. If I distribute the 1, 4, I get n plus 4. Right here, when I times n minus 2, and we've already rewritten that as n minus 2 times n plus 4. When I multiply this by the least common denominator, n minus 2 times n plus 4, both factors cancel out, and I'm just left with the 2n plus 1. And then over here, n minus 2 times n plus 4, the n plus 4's cancel out, and I distribute the 2 through, and I get 2n minus 4. So we have a linear equation. So I gather like terms on the right side. 2n plus 2n makes 4n. 1 minus 4 is negative 3. If I minus n from both sides and add 3 to both sides, I get 7 equals 3n. And if I divide by 3, I get n equals 7/3. Did anybody check for an extraneous solution on this one? I would use your calculator. Huh? It's not extraneous? Okay, Cameron checked. Who else checked? Yeah. Okay, so this one's not extraneous. Good job. Okay, next problem. Whoops, I went the wrong way. Okay, I don't know. I dragged that one. Did we ever do this problem, you guys? We're going to skip it. You guys know how to do those. Okay, we're going to go to number 9. Where do the graphs of 2x plus 4y equals x plus 16 and 1 minus the absolute value of 2x minus 4 equals y intersect? Okay, good job, you guys. Hey, on this one, when you solved it up here for x, here for y, you got 4y equals negative x plus 16. Then you divided by 4, and you got negative 1/4 x plus 4. So we go put these two in our, you guys, listen. Put these two in our calculator. We get negative x divided by 4. You can put it in that way, or negative 1/4 x plus 4. And we have 1 minus the absolute value, 2x minus 4. Hey guys, if we, holy cow, I did something wrong there. No, I just got to delete that. Okay, here we go. You'll notice that they do not intersect. Therefore, there is no solution because they do not intersect. Okay, next problem. I need to make this big so you guys can see it. Okay, solve this system of equations. Y equals negative absolute value of x plus 5. And y equals 2 to the x power. All right, most of you guys only found one of the solutions. Okay, don't forget that an exponential solution goes on forever in the left, for the left. It will never get to that x-axis. It will just get closer and closer to it. Hey, by the way, what did we say we're going to round all our decimal places to, you guys? 3 decimal places. That means you got to round the third one. Some of you guys did not round the third one, so keep that in mind as well. Okay, so when I put these in my calculator, I get negative absolute value of x plus 5. And then 2 to the x power. Don't forget, you guys, over here, at about negative 5, these two graphs intersect. Some of you guys forgot about that one. So I go second, trace button. I go to the intersect, number 5. And I go to the left over here. Close to where they intersect, and I just hit enter 3 times. And you guys, my answer right here, if you round it to 3 decimal places, negative 4.968, comma, 0.032. Check to see if you rounded it correctly. Some of you guys even just rounded the negative 4.968 to negative 5. That's not going to fly on the test, so you know. Our rule is to round everything to 3 decimal places, so round it there. And the other intersection point, well, if it's 4.99999, then if you round it, it's going to be 5, right? I want rounded at 3 decimal places, yep. 4.9999 would be rounded to 5, because that's the next decimal place up. Okay. Hey, that decimal, that intersection right here, you guys, should be 1.716, comma 3.284, if you found that one. Okay? So that is the correct place. All right, next problem. Yeah, now that's correct. Okay, hey, you guys, you'll find out that on this one, you had 2 parabolas that never intersect, right? So no solution. Okay, next problem. Okay, find the key features of f of x equals x to the 4th minus 2x cubed plus 3x squared minus 4x plus 1. Now, the key features are all those things I listed on there except for the multiplicity, remember. You do not need to find multiplicity. I'm going to cancel multiplicity out because we really need to talk about some other things before we talk about the multiplicity. So I want you to find all the key features of the graph. Show me a proper graph, what it would look like. So do all that stuff that was on that assignment we gave you, that list. End behavior, roots, extrema, which are maxes and mins, and so forth. Okay, on this one, we're just going to put it up there and see if you got everything right. So I go to y my y equals, I'm going to put in the x to the 4th minus 2x cubed plus 3x squared minus 4x plus 1. If I graph this one with a zoom 6, hey, by the way, you guys, since this is x to the 4th power, how many possible maxes and mins could it have? How many possible zeros first? Well, if it's to the 4th power, it can have 4 zeros, right? 4 real zeros, but it doesn't have to have 4 zeros. How many turning points could it have? It could have up to 3, right? How many do we see right here? We see 1. So it could actually go up. It might go up, come down over here, and then go back up. I checked a long ways out. Did anybody else check a long ways out? To see. I zoomed out just to see if it was going to cross anywhere else, and then I came back in. How many of you guys came up with a window? I brought my y min up a little bit, and I brought my sides in once I found out it wasn't there. So, I mean, there's not an exact right answer for this always. There's some wrong answers, but there's a lot of right answers. So if I go to my window, I'm going to bring my x min into -4, my x max to +4, and I'm going to bring my y min to -4, and I'm going to hit graph. That's what I did for my window. There's more right answers than that. Okay, first thing I did is I found my zeros. There seems to be some questions about, you guys, when we go to find zeros, about what's left bound and right bound. Let me explain this. On this side, left bound's up and right bound's down. On the other side, the other zero, the left bound is down and the right bound is up. The reason being is because of which way it's slanting. What I want to know is my cursor right now to the left of where it crosses the x-axis? And the answer is yes, okay? You notice when I hit enter, I put my arrow up there, it's to the left of where it crosses. If I go to the right, that's where it crosses. It went to the right. I go a couple more. I hit enter for my right bound. And now I have my 2 arrows saying that my left and right bound are my zeros between the left and right bound up there. Hit enter for my guess. I get 0.309. Does that what you guys got? Comma 0? 0.309 for one of your zeros. My other 0, that's the same thing as a root, right? Does everybody understand that? A real 0 is also a root. There's imaginary zeros can be roots as well, but we haven't learned how to do that yet. So here's my left bound. Here's my right bound. And here's my guess. 1.487, comma 0. Is that what you guys got? Okay, check that one. Isabel, we still got 6 minutes left in class, you guys. 7, actually. We got 7 minutes left in class, so just hang tight. Okay, now I'm going to go find my minimum point. It has a minimum. So I go to number 3, minimum. I have to take my cursor so it's to the left of the minimum. That's to the left. Hit enter. Now it's asking me for a right bound, so I go to the right. Hit enter. Now I go back to where the minimum looks like it'd be about. It looks like it's about at 1 comma negative 1. If I round it, it's 1 comma negative 1, right? So I have a minimum at 1 comma negative 1. That's my min. I'm going to need that number, so I wrote it down. Okay, now, end behavior. What's end behavior, guys? Up to the right and up to the left. Or you can write it like this. As x approaches negative infinity, comma, y approaches infinity, right? And as x approaches positive infinity, y approaches positive infinity. That's saying up to the left and up to the right. Okay? Now, I need to tell where it's increasing or decreasing. As I come from the left, you guys, what's my graph doing? It's decreasing. Till I get where? It's decreasing on the interval negative infinity to 1. Remember, these are always x numbers. And then it's increasing from 1 to positive infinity. No, it's not. Hey, you guys, listen. Increasing and decreasing, when I'm naming the intervals, it has nothing to do with the y. See this? See this y coordinate right here? It has nothing to do with that. It has to do with this 1, the x coordinate. Because I want to know the interval. An interval, an x interval, is the x numbers on which it happens. From negative infinity to positive 1 along the x-axis. If you look right here, here's positive 1. I'm dividing a line. From negative infinity till I get to that dividing line, this function is going down. The y values are decreasing, right? The increasing and decreasing is stating what the y's do, right? What we want to know is the x interval. So, and then from 1, it's going up to the right. So it has nothing to do, when I'm talking about increasing or decreasing, with the minimum y value. It has nothing to do with that. Okay, it's always the x values. You might want to write that in your notes when you study over the next few days so that you don't forget that, because that's a common error. I will mark it wrong if you do it that way. I've told you plenty now, and you're getting a fair warning now, that if you do it that way on your test, it will be marked wrong. Okay? It is not correct. So get that. What's something else that we forgot on there? What's another thing I asked for? The end behavior? We talked about that already. It goes up to left and up to right, and we wrote it right here. Domain and range. What's the domain of this? It's all real numbers. It goes forever left and right. What's the range? Yeah, the range has to do with the y values it takes on. And then we can look at the minimum value of -1 right here. So the range is y is greater than or equal to -1. That would be the range. Or you can write it in interval notation, right? -1 to infinity, yeah. Okay, I'll accept it. Okay, hey, you guys, that's it. We're taking the test next time. Be prepared for it, okay?